Hi boys and girls. So for our lesson today, lesson 13.4, we're going to talk about measures of variability. And that's what we've been doing for the past few days. Remember, a box plot is a graph that shows us how data values vary. Also, the mean absolute deviation tells us, on average, how far apart values are from the mean. And that is a measure of variability. We've talked about variability before this year, and remember that word variability means how different things are from each other. Okay, and so today we're going to spend some more time with mean absolute deviation, and then we're going to learn a couple new ways to measure variability in a data set. Okay, so grab your book if you want to follow along with the examples. Okay, this is lesson 13.4. It says, in gym class, the students recorded how far they could jump. The data set below gives the distances in inches that Manuel jumped. What is the mean absolute deviation of the data set? Now, as you were working yesterday, boys and girls, with mean absolute deviation, it told you the mean and you didn't have to find it yourself. So that's the only thing different that we're doing today. Okay, so today we're going to find the mean, then we're going to figure out how far each value is from the mean, and then find the mean again. So it's not hard, just takes a few steps. Okay, so here's the jumps, okay, in our data set. Okay, and so in order to find the mean, we're going to add all those values together. Okay, so we have 54 plus 58 plus 56 plus 59 plus 60 plus 55. And we're going to divide all of those by 6. Now, just to save time, boys and girls, I've already added those up with my calculator, and that equals 342. And we have 6 data values. And so when we divide that, 342 divided by 6, our mean is 57. Okay? Now, our book uses this fancy table to calculate the distances from the mean. And I think it's very unlikely that you will use a table. And so, boys and girls, all we're going to do is I'm going to go back to my original data set. And I know that the mean was 57. And I'm going to figure out how far away are each of these data values from 57. And I'm going to write it right by that so that we can see. Okay, so I know, boys and girls, 54 and 57, those are 3 spaces away. 58 and 57 is 1 space. 56 and 57 is also 1. 59 and 57 is 2 spaces. 3 spaces and 2 spaces. So those are our distances from the mean. And now we're going to find the mean again, which just means we're going to add those all together. The distances from 57. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're going to divide that by how many we had. 1, 2, 3, 4, 5, 6. And 12 divided by 6 is 2. So what that means is that on average, our data values are 2 away. Okay, so let's talk about variability, boys and girls. We're talking about inches that are in the 50s and 60. Is 2 very much? Not really. Okay, so we would say these data values are fairly close together. They don't vary a lot. Okay, if I were to draw a box plot, boys and girls, using these data values, my box plot's going to be pretty small, right? It's not going to be long and spread out. It's going to be pretty squished together because those data values are pretty close together. So that tells us that data doesn't vary a lot. Okay, on the next page, we're going to learn about something called the range and the interquartile range. So another way, boys and girls, that we can tell the variability in a data set is we can use what's called the range and also the interquartile range. Okay, at the top of the page it says range is the difference. Remember, this word means subtract, right? That's the answer to a subtraction problem. Range is the difference between the greatest value and the least value in a data set. The interquartile range is the difference between the upper quartile and the lower quartile of a data set. Range and interquartile range are also measures of variability. So the range, we take our highest value in a data set and our lowest value, and we subtract those. And that tells us the difference between the highest and lowest. That's a measure of variability. Okay, interquartile range, boys and girls, if you look at this box plot right here, okay, this is the interquartile range, the middle 50% of the data, right? And so we take the upper quartile and subtract the lower quartile. And that tells us what's the difference between that middle part of the data. Okay? All right, let's look at our first example. It says, the box plots show the price in dollars of the handheld game players at 2 different electronic stores. Find the range and interquartile range for each data set. Then compare the variability of the prices of the handheld game players at the 2 stores. So I just want you to look at those box plots. Okay, for store A and for store B. Okay, what do you notice about those box plots? Okay, what I notice, boys and girls, is here, the interquartile range, that middle 50%, remember, this is 25% of the data, this is 25% of the data. Obviously, that data is super close together. This is 25% of the data, and so is that. Okay, that's a super long whisker. Do you remember what we said about super long whiskers? Sometimes those are outliers. Oftentimes they're outliers. Okay, but when we look at store B, that box plot is a little bit more symmetrical. Okay, meaning that it's more evenly spaced out. Okay, this and this are a little bit smaller than this and this. Okay, but it's way more symmetrical than store A. Okay, so let's look at what that data tells us. Okay, so it asked us to find the range and interquartile range for each data set. Okay, so as we look at that, boys and girls, as we look at our box plot, for store A, if we want to find the range, we take our highest value, which is 150, and we subtract our lowest value, which in this case is 24. And 150 minus 24 is 126. And we're talking about dollars. So the range in players for store A was $126. That's kind of a lot. Okay? But when we look at this middle part, the interquartile range, right, from our upper quartile to the lower quartile. Okay, so to find the interquartile range, we take the upper quartile, which in this case is 72, minus the lower quartile, which is 48. 72 minus 48 is 24. I hope. I'm doing math in my head, which is not often a good idea. Okay? Boys and girls, that's a lot closer together. And looking at that box plot, that's not really surprising. It's kind of like scrunched. which means we have a lot of data in that small space right there. Okay, all right, let's look at store B. Okay, so finding the range for store B, take our highest value, which is 120, subtract our lowest value, which is 30. Okay, 120 minus 30 is 90. Okay, still kind of a lot. Okay, finding the inner quartile range, take the upper quartile, which is 100, minus the lower quartile, which is 42. And that inner quartile range is 58. Okay, so definitely less than 90, but not as different as we had over here with store A. Okay, and looking at that box plot, boys and girls, it's easy to see that that data is is a lot more spread out. Okay, and more spread out, boys and girls, means a lot of more variability. When things are super scrunched together, we know that those data values are really close. Okay, because so many of our data values are scrunched here with store A, that means that a lot of their game players cost the same amount of money. Okay, except for maybe this one clear up here that's $150. They have one that's a lot more expensive. Okay, so the range makes it seem like they have a lot, but most of their data values, boys and girls, is down here. Okay, the fact that they have that one expensive game player probably means that most of them are pretty close together, but they have that one that makes it seem like there's a better variety in price. Okay, this is more consistent. Okay, and the data values are more spread out. Their variability, even in the middle, is 58. Okay, so as you are doing your practice today with variability, remember if our data values are really close together, or we have a mean absolute deviation that is fairly small, that means that the data doesn't vary a lot. Okay, if we have a mean absolute deviation that is big, that means the data values aren't very close together, and that would be a lot of variability. Okay, reach out to your teacher today if you need help.